ladies and gentlemen. My name is Vu Duong, spelled out VU DUONG. I come from Vietnam, and I'm working for Duy Tân University. My colleague, the Professor Ashfaq Ahmed from Purdue University Northwest, USA. We are collaborating on these subjects. And here is my presentation on the International Mechatronics Conference, Stillwater in USA. My presentation focuses on following points. We are introduce the mechatronics and integrate approach. How is my difference distinguishable on this integrated approach? First, the vision of CDIO initiative is to provide students with the education that stress engineering fundamental set in context of 4 stages: conceiving, designing, implementing, and operating in real-world system, process, and product. The second, customize the integrated approach. Standard number 3, in teaching the technical discipline, for example, adding the manufacturing processes. The next, an integrated curriculum should also focus on workplace environment to implement on-site practice. It means standard number 6. Unique teaching and learning, standard number 7. Problem-solving skill, standard number 8. So, it would be attractive and very useful for developing production skill for engineers. And the last one, the integrated approach presented in this paper for introducing the technical discipline help students identify urgent socio-economic problems, integrate different skills and know-how for feasible solution. Here, we introduce 4 parts. First, introduction. The second, CDAO standard number 2, number 3, refocus for concept and design stage. Next, refocus of standard number 6, 7, and 8 in implementation and operation stages. And the last one, conclusion. Here, I would like to pay some attention for mission of our Duy Tân University. As I told you, I am working for Duy Tân University. And here, what we can see, Duy Tân University mission is to focus on in-depth training and research of technology and science in order to produce graduates with recognizable level of patriotism, confidence, creativity, flexibility, humanity, community service, and wellness, besides essential skill and capability to become an entrepreneurial and global citizen. Here, we pay attention on what? Humanity. And this is also the difference in my integrated approach, because except the simultaneous apply all standard in the preparing curriculum and also in teaching, we pay attention on humanity side of our teaching activity, and we will show how we can integrate this side in preparing curriculum and teaching our Vietnamese students. As we know, the invalid, they may be from the war, from traffic, from production or inborn, and which difficulties face the disabled people. First, moving ability. The second, self-carrying out, very difficult. And the last, doing usual duty. So, what can we do to help to resolve this problem for disabled people? This is mind map on electric wheelchair, and our student pay attention on this product. On the stage concept, all students freely discuss on all problem, and they can propose any model, any opinion, and they can discuss between them. But the instructor always follow and make many advice as coordinator, so that our teaching staff can help them to develop ability, guidance skill, systematic thinking, creative thinking, and selective precise problem resolving. This is the content of the standard number 2 in CDAO standard. Namely, the student have to identify practical problem related to their subject matter, mainly in the area of mechatronics. Also, we have them to visualize that they have learned through discussion with company and disabled association. We also encourage all students to be receptive to make change in their initial plans based on the information they obtain in the meeting with disabled people, with association, with company. We can apply also the flexible model to catalyze discussion, giving student personal viewpoint on discerning information. But we focus on problem. Which problem? Which might be social in nature or demanded by the company in the area of mechatronics. Because as we told for the first moment, we especially pay attention for human side in teaching, in research, in all education activity. And this different from our methodology. We not only apply CDAO standard, we apply simultaneously some standard in preparing, in teaching, in education activity. But we also pay attention of students on human side in education, human side in teaching, technical discipline. If this is the difference of our job. And finally, the instructor played the role of facilitator, bridging and connecting on information, managing student team to conceive the idea, guide and trigger the technological engineering aspect to help them complete their engineering conception. Here you can see our teaching staff with our student. The teaching staff, the instructor help student to formulate the model, formulate the mind map. And finally, wheelchair was created by our student using the above mentioned cycle. Yes. What difficult for the disabled people. They face the problem very difficult to move, to do their usual duty. So if we pay attention on the something like a wheelchair, so we have to design for very smooth and quickly disassemble in some seconds. It will be very useful, and students work hard on the design of the dismantle mechanism, so that user could assemble and disassemble very quickly in few minutes. This is the core value. This is the core value of student design. So we finalize the first stage, concept. Now we pass to the second stage, stage design. Student team contacted with the disabled association and even contact with their family to so that they can approach people very close contact and have any necessary information to be improved their design. Which the role of instructor in this stage? Instructor is responsible for arranging and contacting the disabled association, their family, local authority to provide suitable setting for students to do a survey and complete their investigation. And then based on this data collected on the site investigation, students change opinion, analyze and propose some design and this engineering detail for the wheelchair, as we can see on the figure number 3. Here, students team in our workshop in university, they are collaborating, they are changing, they are thinking, and they are finalizing the design on the wheelchair model. Now we can pass on the next stage of CDIO methodology, namely implementation and operation. Here we can see how we simultaneously apply, on the same time, apply on this standard number 6, number 7, and number 8 in implementation and operation stages. Following a chain of 20 activities, all students are asked to actively suggest implementation their models, fabrication proposal, product analysis in small team. They are required to do collaboration, discussing, propose, and critique each other and provide feedback. Here, in this stage, we provide students the knowledge and experience in fabricating a wheelchair for improving practical and professional skill, the problem-solving skill. This is the content of standard number 8. And next, students acquire syntactic ability by themselves in one assignment, including product analysis, engineering design, and especially be responsible for social obligation. This is quite unique teaching and learning activity, and this is the content of standard number 7 in CDO project, which we implemented in recent semester using working technical space for students. As you see, we organize teaching, education, teaching activity in on-site workshop, and this is concerned the standard number 6. How we can see on this stage, we show students the useful application, the knowledge of some other subject, some other tool to improve their implementation stage. Namely, we apply the Microsoft Visio, AutoCAD, Autodesk Inventor to develop and simulate the mechanics. We can also encourage students to implement AutoCAD and Autodesk to model, then use the 3D printer to make some detail of prototype. And we understood, students also understood that this is very basic skill integrated in curriculum. Yes. To design, implement the product, standard number 2, number 3, and learn necessary entrepreneurial skill. Okay. The last stage, as we understood, the last step in CDIO methodology is the operation. What students are doing on this stage, they have to test the quality of wheelchair under test condition right in company workshop. As we see here, under guidance of our instructor, students test the wheelchair. Here, a student finished already the design of wheelchair and engineering the wheelchair in CE workshop. CE means Center of Electrical and Electronic Engineering. Normally, in what difference in advanced CDIO projects? In advanced CDIO project, we targeted on additional tools, providing students some more experience and entrepreneurial skill. So we got more criteria for evaluation, practicability, completeness, and flexibility in production conditions. Normally, one project is evaluated by a complex series of criteria as relevance, fulfillment of objective, efficiency, effectiveness, impact, and sustainability. And here, as instructor, we follow all criteria, but we pay more attention on entrepreneurial skill and integrated approach in assessment. Finally, we have some conclusion in our presentation. First, the project Engineering Wheelchair for Disabled Person is a typical example of integration and simultaneous implementation of some complex CDIO standard. For what? To strengthen, upgrade professional skill for students in general, but especially for students in mechatronics and mechanical engineering program. This is the new approach for circumstance analysis practice to set social obligation for students in market study. The next conclusion which we can make, it is important to note that while the students are enrolled in the course Introduction to Mechatronics, they need to learn not only prerequisite subjects, but also need to understand human obligation to successfully contribute to the society. And the last one, Based on this approach, we continue to develop the curriculum with many our design projects in automation, in more higher level, for example, robotics. For example, design the robot system for wind quality inspection. This is our next research which we are doing in my center. Here we can see, everybody can see how she is happy when she got the wheelchair which our student team made by themselves and presented. So this is the meaning of the human activity in teaching, in preparing curriculum, in preparing program education for mechatronics. Finally, I would like to say my thank you for all members who are working in my center, and because they made all efforts to this job. I also express my sincere to my colleague, Professor Ashfaq Ahmed, who is teaching in Purdue Northwest University, USA. Again, thank you so much for your attention. Sorry.